Hello students, welcome to IMS GATE Academy. I hope you are enjoying the sessions on the foundation course. As part of this activity, I have already explained the index properties. Now I am here to explain you the consistency limits. My dear students, if you like this session, please share to the real GATE aspirants so that they can use these sessions and they can take it as a reference for future GATE preparation. So the agenda of the today's topic is nothing but the consistency limits. So let us discuss, I have told in the previous session also, what do you mean by consistency limits, my dear student? When I talk about the consistency limits, here you should be very clear, my dear students. Here you should be very clear with some things. Like what we have to be clear, I'll show you here, students. What actually is consistency limits, or what actually do you mean by Atterberg limits? Consistency limits or Atterberg limits are nothing but both are same. Okay, my dear students, what do you mean by consistency limits or Atterberg limits is they are the water contents at which the soil passes from one state to the other state. They are the water contents at which the soil passes from one state to the other state. So here, my dear students, there can be a liquid state, there can be a solid state, there can be a semi-solid state, or there can be a plastic state also. So let us discuss what actually they are and what do you mean by those. So here I am just drawing the diagram, students. So let us see here. So let us see, students, here when I talk about the important concept, it is a graph drawn between volume. A graph is drawn between volume and also a graph is drawn between water content. Okay, WC is nothing but the water content. So here, my dear students, when I talk about the consistency limits or Atterberg limits, what is actually a consistency limit or Atterberg limits? So let us see here. My dear students, what do you mean by consistency limits, or consistency limits are also known as what, my dear students? They are also called as Atterberg limits. So let us see, here we have the volume seems to be constant, and here this position is called dry volume, and here this point is called shrinkage limit, and here this is called the plastic limit, and here this is called the shrinkage limit. And here we have the liquid state, here we have the liquid state, and here we have the plastic state, and here we have the semi-solid state, and here we have the solid state. So whenever you are talking about the consistency limits, my dear students, you should be aware of this graph. This graph is a graph drawn between the volume and the water content. So what are consistency limits, are also called as what, my dear students? Consistency limits are also known as Atterberg limits. Consistency limits are also known as, my dear students, they are also called as Atterberg limits. Or you can write here, my dear students, these are the water contents at which soil passes from one state to the other state. So consistency limits or Atterberg limits means these are the water contents, at which soil passes from, one state to the other state, at which soil passes from one state to the other state. What is one state to the other state? Or you can see from the diagram, my dear students, they are like a border. If you see the Atterberg limits or consistency limits is, they are like a border. Suppose if you consider shrinkage limit, it acts as a border between solid state and semi-solid state. Once the shrinkage limit was crossed, the water content, then it will enter into the semi-solid state. Similarly, if it has crossed the plastic limit, it will be into plastic state. And if it has crossed the shrinkage limit, then it is called liquid state. Sorry, here it is called liquid state. I have written it as, one second, students. Here you have to write it as liquid state. So from the graph, it is evident that liquid limit is greater than, plastic limit is greater than, shrinkage limit. From the graph, what is evident? Liquid limit is greater than, plastic limit greater than shrinkage limit. You can ask me, sir, you have told in the previous sessions, then why are you teaching now? See students, without this graph knowledge, you cannot solve the problems. So you should have at least an idea what is liquid limit, what is plastic limit, and what is shrinkage limit. So coming to the shrinkage limit, so see up to here, when you see the volume change, there is no volume change. It is the shrinkage limit is defined as the maximum water content up to which the volume remains constant, or it is the maximum water content up to which any loss of moisture does not cause any change in the volume. I repeat the thing, it is the maximum water up to which any further loss of moisture does not cause any change in the volume is known as shrinkage limit. So when I talk about the shrinkage limit, my dear students, when I talk about the shrinkage limit here, I just want to tell you what do you mean by shrinkage limit here. When I talk about the shrinkage limit, what are the important formulas you should remember when I talk about the shrinkage limit. So when I talk about the shrinkage limit, my dear students, here shrinkage limit is given by the formula E upon G, or it is the water content. See here, it is the minimum water content at which the soil is fully saturated. Suppose we know already the relation between void ratio, water content, specific gravity and degree of saturation. When I talk about the void ratio, water content, degree of saturation, suppose my dear students, here in fully saturated, the degree of saturation will be equal to 1. In this case, the water content minimum will be equal to the shrinkage limit, and if you substitute this value in the equation, you will get shrinkage limit is equal to E upon G. And remember, my dear students, there is another formula for shrinkage limit is also given by the formula 1 by Gm minus 1 by G, where 1 by G represents the mass specific gravity and G represents the true specific gravity. So these two formulas will definitely help you in solving the shrinkage limit problems. Now, my dear students, when I talk about the shrinkage ratio, we have a term called shrinkage ratio. What do you mean by shrinkage ratio? In loose words or in simple words, it is the mass specific gravity at dry state. What is shrinkage ratio, my dear students? As I have previously explained, it is the mass specific gravity. Shrinkage ratio is defined as the mass specific gravity in which state, students? It is defined as the mass specific gravity in dry state, or you can write it as gamma D upon gamma W. So this is nothing but the shrinkage ratio. Or you can also write that shrinkage ratio is defined as the volume change, whatever the volume, there is a change in the volume change expressed in terms of dry volume. You can write here, students, volume change expressed in terms of dry volume, change expressed in terms of dry volume to the corresponding change in water content, So here, my dear students, suppose if I have taken shrinkage ratio formula, if I take the volume at liquid limit is VL and the volume at shrinkage limit is VD upon, in terms of dry volume is VD divided by liquid limit, the volume at liquid volume, the limit will be liquid limit, and at dry volume the water content will be plastic limit. So this formula can also be understood while you are studying about the shrinkage ratio. What do you mean by shrinkage ratio? It is the mass specific gravity at dry state, or it is defined as the volume change expressed in terms of dry volume to the corresponding change in water content. So here we are clear. If you see the graph, students, we are clear with the shrinkage limit. When I talk about the plastic limit and liquid limit, they are direct theoretical experimental definition. It is the minimum water content. Suppose if you add some water into the soil and you make like a rope of 3 mm diameter, whatever the minimum water you can make it like a rope without breaking, that will be nothing but the plastic limit, and it is also called as a thread test. What is liquid limit? You might have studied in our previous sessions. What is a liquid? A liquid is easy to flow. Why it is easy to flow? It has no shear resistance. But at liquid limit, there will be small shear resistance for the flow. If you cross the liquid limit, then the state is known as liquid state. Are you following, my dear students? Any doubts in the liquid limit, plastic limit and shrinkage limit? I hope you are clear with the concept. Now let us start the problem, students. Let us start the problem. So we have a beautiful problem. So slowly I will enter into the difficulty. I will increase the problems from basic to the standard, high standard problems. So here we have a beautiful question, my dear students. What is the beautiful question is, a clay sample has a void ratio of 0.5. So the void ratio was given in the problem was 0.5. Remember, my dear students, whenever you are writing a GATE exam, the first and the foremost to solve a problem is first write the given data. When you can write the given data, with the given data, you can write your own equation or you can remember that equation. So please use some time to read the data. So here void ratio is 0.5 under the dry condition. The grain specific gravity is determined by 2.72. What is the shrinkage limit? So the problem is simple. When I talk here, we have so here void ratio is given as how much, students? 0.5 and the specific gravity is given as 2.72. When I told you that void ratio is 0.5 and specific gravity is 2.72, what is the formula for shrinkage limit? Shrinkage limit is nothing but E upon G, because it is the minimum water content at which the soil is fully saturated. So just take the value of void ratio 0.5 and the specific gravity value is 2.72. So can anyone tell me the answer, my dear students? Can you please post in the chat box what is the answer we have? So let us see, we have a calculator here. So if I talk about the shrinkage limit is how much, students? So 0.5 divided by, what is the specific gravity? It is 2.72. So if I talk here, the value is 0.1838, or you can write it as, if you talk in percentile, it will be 18.4 percentile. So whenever they have given you the void ratio and specific gravity, how easily you can solve this problem is, if you can remember that shrinkage limit is the minimum water content at which the soil is fully saturated. At this juncture, you have to substitute the degree of saturation value as 1. I hope you are clear. Now let us go to the next problem. Now my dear students, there is a beautiful problem here. The unit weight of sand backfill was field measurements was found to be 1746 kg per meter cube. So what is given in the problem? The unit weight, that means gamma is nothing but 1746 kg per meter cube, and the water content of the soil is 8.6 percentile. What is the water content of the soil, my dear students? The water content of the soil is 8.6. And the unit weight of here soil consistency is 2.6 gram per cc. In the laboratory, the void ratios in the loosest and densest state are found to be 0.462 and 0.642 and 0.462. What is the relative density? So see, students, here I will talk about the relative density. Okay, they have given you gamma, that is 1746 kg per meter cube. The unit weight of the soil is 1746 kg per meter cube. And the water content is how much? It is 8.6 percentile. Okay, so you can write it as 0.086 if I am not wrong. And if the void ratio is loosest, so here comes, my dear students, they have not given the void ratio as maximum. They have given the void ratio in loosest. There comes the concept. When the void ratio is loosest, in loosest state, the void ratio will be maximum. So the maximum void ratio is given as 0.642. And the void ratio in the densest state, the void ratio will be minimum. So here it is 0.462. And For specific gravity, my dear students, when I talk about the specific gravity is nothing but gamma S by gamma W. My dear students, most of the students while solving this problem, they will feel that specific gravity is not given. But don't panic, my dear students. They have given you the gamma S value, that is 2.6 gram per cc. When they give you gamma S as gram per cc, you know G is equal to gamma S by gamma W. 2.6 gram per cc upon gamma W in terms of gram per cc will be equal to how much, students? Can anyone tell me? 2.6 gram per cc. And if you talk about gamma W, it will be 1 gram per cc. So the G value will be equal to 2.6. Remember, G is defined as the ratio of unit weight of solids to the unit weight of water. So here they have asked what is the relative density. So here, my dear students, when I talk about the relative density formula, relative density is also known as density index. It is given by the formula E max minus E upon E max minus E minimum. So my dear students, if you see the problem, they have given everything. They have given the void ratio in the loosest state and they have given the void ratio in the densest state. Or they have given you the maximum void ratio and also the minimum void ratio. They have given you both the values of maximum and minimum, but they have not given you the void ratio. So the void ratio in natural state. But see, students, when I talk about the void ratio, we have a equation gamma D is equal to gamma W into G upon 1 plus E. Now, my dear students, you know gamma W, you know G, and you can find E from this equation. But how do you find out gamma D? Gamma D. So gamma D is given by the equation bulk unit weight upon 1 plus water content. So they have given you gamma is equal to 1746 kg per meter cube, students. If you convert this value, my dear students, if you convert the gamma value in terms of gram per cc, it will be equal to 1.746 gram per cc. So when I talk here, gamma D is equal to 1.746 upon 1 plus 0.086. So here I have converted into gram per cc, students. So let us do the calculation part. Here if you talk about gamma D, so here we have gamma is how much? 1.746 divided by 1.086. So we have a value got. How much is the gamma D? Gamma D is nothing but 1.607 gram per cc. So here immediately students will ask me, sir, why you have taken, you can take it as 1.60. But see, students, when you see the void ratio here, they have given the values up to 3 decimals. So that is the reason even I have taken the dry density up to 3 decimals. So let us see, students, gamma D is equal to 1.607 gram per cc. Now, my dear students, when I apply the formula, gamma D is equal to what, my dear students? Gamma D is equal to, you can write this formula here. Gamma D can be written as, dry density can be written as what? Gamma W into G upon 1 plus E. So gamma D is how much? 1.60. Gamma W is 1. G is 2.6 divided by 1 plus E. So if you solve this equation, you will get void ratio as 0.617. What is the void ratio you will be getting? Void ratio you will get as 0.617. But did they ask you the void ratio? No. They have asked you the relative density, that is ID is equal to E max minus maximum void ratio minus void ratio in natural state upon E max minus E minimum, my dear students. So here what is E? E is nothing but the void ratio in the natural state. What is E max? Void ratio in the loosest state. So here you know all these values. So E max value is given as 0.642 minus, what is the void ratio in natural state? Anyone, my dear students, what is the void ratio in natural state? You have got it as 0.617 divided by 0.642 minus 0.462. If you want to get into percentile, you have to multiply with 100 and you will get a value of around 13.8 percentile. You'll get a value of, or you'll get the value, if you don't multiply with 100, it will be 0.138. Now, my dear student, in this problem, they've asked just the relative density. So, you have told it is 13.8 percentile. But in the some other problems to see students, in the some other problems, what they can ask you is, they can ask you what is the state of the soil. See students, if they ask you what is the state of soil, this question can also be asked. So if they ask you what is the state of the soil, here if you see the density index, if the density index is 0 to 15, okay, the state of the soil is, if the density index is 0 to 15, the state of the soil is very loose. If it is 15 to 35, if it is 15 to 35, it is loose. And if it is 35 to 65, it is medium dense, or you can dense, low dense you can write. If it is 65 to 85, it is dense. And if it is more than 85, you will write it as highly dense. Now, whatever the value you got is 0 to 15. So, the answer will be here, my dear students. Here you got 0 to 15. If they ask you what is the state of the soil, very good, Sai Srujana. Very good, Amma. Very good, Sai Srujana. Very good. Here density index is very loose. So, Sai Srujana, is the density index clear for you? Density index is defined as the maximum void ratio minus the void ratio in natural state upon maximum void ratio minus minimum void ratio. Here, what I would like to tell you is, when will be the void ratio maximum? The void ratio will be maximum in case of loose state. The void ratio will be minimum in case of dense state. Through this formula, thank you, you are clear now? Now, let us see. This is a classical problem. Try to understand this problem also. The plastic limit and liquid limit of a soil are 33 percentile and 45 percentile. What is the value, sir? 45 percentile and 33 percentile respectively. The percentage volume change from liquid limit to dry state is 36 percentile. Agree? And similarly, the percentage volume change from plastic limit to dry state is 24 percentile. Calculate the shrinkage limit and shrinkage ratio of the soil. So, Srujana, here they have asked, what they have asked you? What is the shrinkage limit and what is the shrinkage ratio? Is the question clear for you? What they have given, my dear students? Here they have given you the liquid limit, plastic limit, as well as the volume change. So, for this, how do we do this problem? So, let us see this problem, how this problem can be done. So, here please see students. Now, see students. Here we will draw the lines. Okay. Now, see students, they have given this. See here, always. Here this point is called what, students? This is the shrinkage limit. What is this point called? Plastic limit. And this is liquid limit. If you see the question, students, what is the liquid limit given there? The liquid limit is given as 45%. What is the liquid limit given in the problem? Liquid limit is 45 percentile. And what is the plastic limit is given as 33 percentile. Okay. In addition to these, students, what they have given, we will see. They have given the volumes. Okay. So, see students, if you consider this as volume at liquid limit and this is the volume at plastic limit, and this anyhow you know this is the dry volume. So what they have given is the volume change from liquid limit to dry state is given as 36% of dry volume. Okay. Clear, Srujana? Are you clear? Okay. Similarly, the volume change from plastic limit to dry state is 24 percentile of VD. It is how much, students? It is 24 percentile of VD. So here they have given you that the volume change from liquid limit to dry state is 36 percentile. The volume change from plastic limit to dry state is 24 percentile. So what will be the change from liquid limit to plastic limit? If the total is 36 and this is 24, so 36 minus 24 will give you the volume change from liquid limit to plastic state. So that will be equal to 12 percentile. So first what they have asked us, they have asked you what is the shrinkage limit. So before doing the shrinkage limit, let us do the shrinkage ratio. What is shrinkage ratio? Shrinkage ratio is defined as the volume change expressed in terms of dry volume to the corresponding change in water content. Sir, you can ask me, this is the beautiful thing, and you have to use your common sense also, students. Sir, you can ask me, why you have taken VL minus VP upon VD by WL minus WP? Sir, why can't we take VP minus VD by WP minus WS? Remember, students, why I have taken this formula, shrinkage ratio, this formula only because in the problem, they have given us the data related to liquid limit and plastic limit. So the values which you know are liquid limit and plastic limit. So that is the reason I have taken this, because shrinkage ratio can be expressed in different way, different formulas. But as the problem has given the data liquid limit and plastic limit, I have solved this. Clear? So now what is the volume change from liquid limit to plastic limit? It is 12 percentile. So here, if I write here, my dear students, shrinkage ratio. Srujana, is it clear for you? So here shrinkage ratio can be written as volume change from plastic limit to dry state is 12 percentile of VD upon dry volume. What is the liquid limit they have given? Liquid limit was given as 45 minus 33 percentile. So the shrinkage value will be equal to how much? So the shrinkage, very good. So the shrinkage value will be equal to how much, sir? Shrinkage ratio will be equal to 1. Now see, students, they are asking you what is the shrinkage limit. Now it is a slope, so you can take that slope. If you take the slope, now you can find out the shrinkage limit. So can I write the generalized equation? Suppose VL minus VP upon WL minus WP can be written as VP minus VD upon WP minus WS. Okay. Now see, what is the volume change from liquid limit to plastic limit? What is the volume change from liquid limit to plastic limit? It is 12 percentile of VD. What is the volume change from plastic limit to dry state? It is 24 percentile. So this is 12 percentile VD and VP minus VD is 24 percentile VD. So see, students, what is liquid limit minus 40, plastic limit? 45 minus 33 is upon, what is plastic limit? 33 minus WS. Everything is in percentile, my dear student. So here, see, Srujana, I have cancelled VD and 24 and 2. You will get this as 12. So 12 cancel. You can write here 33 minus 12, 45 minus 33 is 12. 12 upon 12 is 1. So 33 minus WS is equal to 24 percentile. So shrinkage limit can be written as 33 minus 24 percentile. That will be equal to 9 percentile, or in terms of value it is 0.09. So my dear students, whenever you are solving this problem, if you don't understand the graph, you cannot solve this problem. So here you should know that where it is liquid limit. So you at least or see the order. Liquid limit is more than plastic limit is more than shrinkage limit. So they have given at liquid limit the volume changes. They have given the liquid limit value as how much, sir? Here they have given the liquid limit as 45 and the plastic limit was given as 33. And they have given you the volume change from liquid limit to dry state is 36 percentile and the volume change from plastic limit to dry state is 24. So the remaining will be 36 minus 24. That value will be equal to 12 percentile of VD. Am I clear? Is this clear? Now with this we are done with that problem. Now next problem what is? The mass specific gravity of a fully saturated specimen of a clay having 40 percentile is 2.88. Having 40 percentile is how much, sir? 2.88. On woven drying, the mass specific gravity drops to 1.74. This is a very important question, my dear students. Initially, the soil is saturated. Now it is kept in woven drying and now the state of the soil is dry. So you have to understand here, see students, I would like to explain you. The mass specific gravity of a fully saturated specimen of a clay having water content 40 percentile is how much, sir? Having water content of 40 percentile is, having a water content of 40 percentile is how much, students? 40 percentile is 1 point. On woven drying, the mass specific gravity drops to 1.74. So here what I would like to tell you is, initially the state of the soil is saturated. So after woven drying, now the state of the soil is dry state and the specific gravity is 1.74. Calculate the specific gravity of the clay, shrinkage limit they are asking, see. They are asking what is specific gravity, shrinkage limit and shrinkage ratio. They are asking all these three. What is the specific gravity, shrinkage limit and shrinkage ratio? These are the three things they are asking in the problem. So let us solve this problem, students. So initially the saturated unit weight is given as how much, sir? The mass specific gravity, sorry. They have given the mass specific gravity, that is gamma sat by gamma W is 1.88. In which condition they have given? Saturated. Sir, you can ask me this formula. Sir, what is mass specific gravity? I told you already in the previous sessions. It is defined as the ratio of, Atul, tell me, sir. You have any doubts, Atul? Do you have any doubts here? Is it clear? Okay. Now what I would like to tell you is, mass specific gravity is defined as the ratio of unit weight of soils. Here they have told it is a saturated condition. So it is defined as gamma sat upon gamma W. Sir, what is the weightage of this topic in GATE exam? Atul, usually consistency limits, we are going to get 2 marks, Amma. That is a very good question. There can be a 1 mark or 2 marks. But this topic is the like a basic. If you want to classify the soil, suppose whether it is a fine grained or a coarse grained, these indices, whatever you are learning, that is liquid limit, plastic limit and shrinkage limit, and we have associated with the plasticity index, liquidity index, toughness index. Actually, this will help you to classify the soil, whether it is a fine grained or a close grained, and also in the fine grained, it will also help you to classify the clay or silt. That is a very good question. And remember, Atul, I would like to add one more point. Geotechnical is a very, very important subject in civil engineering. It carries almost 10 to 14 marks. On an average, you will be getting 12 marks. Suppose if you are a real GATE aspirant, my dear student, Atul, there is a total civil engineering is for 100 marks. If you can secure 12 marks from geotechnical and 8 marks from environmental and 8 marks from transportation, and with 25 marks in maths and aptitude, definitely your rank can be below 1500. So that is the importance of the geotechnical subject. So if you are really interested, please share this session and follow this session regularly. So here the mass specific gravity of the soil is given as gamma sat upon gamma W is 1.88. So you know, my dear students, the saturated unit weight is given by the formula gamma sat is equal to gamma W into G plus E upon 1 plus E. So here when I talk about G plus E upon 1 plus E, G is nothing but the specific gravity and E is known as the void ratio. So here I can write gamma sat by gamma W is equal to G plus E upon 1 plus E. My dear students, suppose here we have two unknowns. What is the two unknowns we have? One is the void ratio and specific gravity. But you have only one equation. So how can you overcome this? So they have given the water content is given as 40 percentile. So from the relation E is equal to water content to G upon SR, you know in case of fully saturated, the state of the soil is what, my dear student? The state of the soil is fully saturated. In that case, the degree of saturation value will be equal to 1. In case of fully saturated, the degree of saturation will be equal to 1. So here it will be taken as water content is how much? 0.4 and specific gravity is G. So I will take this value as 0.4 into G upon 1. So my dear students, now I have converted the void ratio into specific gravity. One equation you can easily solve. What is the value of gamma sat by gamma W? It is nothing but equal to 1.88. So here we have G, here we have G plus E is equal to 0.4 G upon 1 plus E, 1 plus 0.4 G is equal to 1.88. Now my dear students, what is the value of specific gravity here? The value of the specific gravity here, it will be equal to the 2.9. The value of the specific gravity will be equal to how much, sir? It will be equal to 2.9. Any doubts, Srujana and Atul? Is this problem clear for you? Any doubts in this? So here, my dear students, whenever there is a problem, you have to understand the given data, whether the state of the soil is saturated, and through saturated state, how you have calculated that is specific gravity. And remember important thing, students, the specific gravity for a soil, whether it is saturated state or dry state or anything, the specific gravity remains constant. For a given soil, the specific gravity always remains constant. So you have calculated the specific gravity G is equal to 2.9. Now comes the question, what is shrinkage limit? So as we discussed already, what is the formula for shrinkage limit? The present state. What is the present state? Sir, this is a very, very important problem. Here the shrinkage limit is taken as 1 by Gm minus 1 by G. How we solve the problem? 1 by Gm minus 1 by G into 100. So see students, most of the students, they will take mass specific gravity value as 1.88. That is absolutely wrong. That is absolutely wrong. Why? Because the saturated state was changed to dry state. Why it is changed? Because you kept in a woven drying. So the GM value, what you have to consider now is 1.74. See students, this is the common mistake everyone will do. The present state of the soil is dry state. So I have taken GM as 1.74. So we can write this value as 1 divided by 1.74 minus 1 upon 2.9. Can anyone tell me what is the answer? Quickly, into 100. If you multiply with 100, you will get the answer in percentage. Can anyone tell me quickly, students? What is the answer we have here? So here if I see, what is the value? 1 divided by 2.74 is how much you got? 0.3649. Okay. So here we have the another one is 1 divided by 2.9. It is how much, sir? 0.348 minus 0.3649. If I do it, it will be. So you will get the shrinkage limit is how much, sir? What is the value of shrinkage limit? 3649. How much you got? Anyone, my dear students? Very good, Rai Srujana. Very good, sir. You will get a value of 0.229 into 100. That will be equal to 22.9 percentile. Srujana, are you clear? See, we have a formula, shrinkage limit is equal to 1 by Gm minus 1 by G. But the condition of the soil is now dry state. So are you clear, Srujana, why we have taken here Gm as 1.74? Because after saturation, the present state is dry state. You have to always calculate the shrinkage limit at the present state. Clear, Srujana? Is this clear? Okay. Now, we are also done with the shrinkage limit. They have asked you what is shrinkage ratio. Sir, shrinkage ratio is given in the problem itself. It is nothing but 1.74. Why shrinkage ratio is 1.74? Why shrinkage ratio is 1.74? Because it is defined as the mass specific gravity. Very good, Srujana. Shrinkage ratio is defined as the mass specific gravity in dry state. Here shrinkage ratio is taken as how much? Its shrinkage ratio is equal to 1.74 because the shrinkage ratio is defined as the mass specific gravity in dry state. Remember, my dear students, shrinkage ratio is defined as what? It is defined as the mass specific gravity at dry state. If you know that statement, directly you can answer the question. No need to solve anything. Directly you can write. Now see students, a soil has a liquid limit 35 percentile. A soil has a liquid limit of 35, plastic limit 20, shrinkage limit 10 percentile, and a moisture content is 25%. What will be the liquidity index, plasticity index, and shrinkage index? Now see students, clearly they have given you all the values. When they have given you clearly, my dear students, liquid limit is 35 percentile, plastic limit is 20 percentile, and shrinkage limit is 10 percentile, and the natural water content is 25 percentile, and the natural water content is 25 percentile. So he is asking first the liquidity index. Srujana, can you give a try on this problem? So here, when I tell you about the liquidity index is given by the formula W minus WP upon IP. What is IP, my dear students? IP is nothing but the plasticity index. So here IP is calculated as WL minus WP. What is WL minus WP? WL is 35 percentile minus 20 percentile. That value will be equal to 15 percentile. So WL minus WP is given as 35 minus 20, 15 percentile. You have the natural water content as 25 percentile minus 20 because the plastic limit is 20 upon plasticity index is 15 percentile. You will get a value of 1 by 3. That is equal to 0.33. So remember, my dear students, liquidity index is taken as 0.33 and plasticity index is 15 percentile. So plasticity index is 0.15. Okay. Now when I talk about the shrinkage index, what is the formula for shrinkage index? Srujana, can you tell me this? What is the formula for a shrinkage index? Shrinkage index is given by the formula. Shrinkage index is given by the formula IS is equal to WP minus WS, where WP indicates the plastic limit and WS indicates the shrinkage index. So shrinkage limit, sorry. Here what is the plastic limit we have? Plastic limit is given as 20 percentile and shrinkage limit is given as 10 percentile. So 20 minus 10, that will be equal to 10 percentile. So you can write it as 0.10. So if you see here, my dear students, what is the plasticity index? What is the plasticity index? Plasticity index is, sorry, IP is equal to 0.15. And if I talk about the shrinkage index, it is equal to 0.10. And what is the liquidity index? Liquidity index is equal to 0.33. So I hope you are clear with the indices, that is plasticity index, liquidity index and shrinkage index. Is this clear, Amma? Any doubts in this problem? It is a direct formula substitution. If you remember the formulas, just plug in that values, you will get the answer. Now see students, we are talking about a soil called here the coefficient of uniformity and curvature of a soil are 4 and 1 respectively. The ratio of D30 upon D10. They have given you clearly, see students, the coefficient of uniformity. So here coefficient of uniformity is defined as D60 upon D10. Now immediately you can ask me, my dear students, why do you want to study about coefficient of uniformity? Coefficient of uniformity will give you an idea about the particle size range, from which minimum size particle to which maximum size particle the soil is varying. You will get an idea by learning coefficient of uniformity. When I talk about coefficient of curvature is given by the formula d square 30 upon d60 into d10. Here, my dear students, when I talk about the coefficient of curvature, you talk about the, why do you want to learn about coefficient of curvature? See students, when you talk about the coefficient of curvature, here you should have, why do you want to study about curvature is, you will get the shape of the curve. Because when you talk about well-graded soil or poorly graded soil or uniformly graded soil, these coefficients are very helpful. If you tell it is a well-graded soil, particles of all sizes are present. If you tell it is a poorly graded soil, some particle sizes are missing. If you tell uniformly graded, all the particles are of same size. Based on the Cu and Cc values, you will tell whether it is a well-graded or poorly graded. Remember, my dear students, for a soil to be well graded, it should satisfy both the conditions of Cu and Cc. Now let us see, the problem is very easy. Cu was given as taken as 4 and Cc is taken as 1. Now see students, if I see here, if I write here Cu into Cc, what is Cu? You can write here as d60 upon d10. And what is Cc? d square 30 upon d60 into d10. Okay. Now see students, this can be d60 cancel. You can write it as d square 30 upon d10 square. So, but the problem they've asked you, what is the value of d30 upon d10? When they ask you what is the value of d30 upon d10, just take the square root of Cu and Cc. If you take the square root of Cu and Cc, you will get the value of d30 and d10. Cu value was given in the problem as 4 and Cc value as 1. So the d30 upon d10 value is 2. It cannot be negative, sir. Don't think, sir, what actually square root means plus or minus 2. Never the d30 and d10 values will be negative. Why? Because what does d30 represents? It is the size of the sieve where 30% is passing. D10 means it is the size of the sieve where 10% is passing. So there is no point of negative there. Now see students, this is another important problem, means simple problems. The liquid limit of a clayey soil was 56% and its porosity index is 15%. And its porosity index is how much? It is 15%. The state of the soil at a water content of 45%. Srujana, are you following? So here, my dear students, the solution here is liquid limit is how much, sir? Liquid limit is 56 percentile. Liquid limit is 56 percentile. And the plasticity index is how much? It is equal to 15 percentile. Now, using plasticity index and liquid limit, can we find out plastic limit? IP can be written as plasticity index is equal to WL minus WP. That is equal to liquid limit minus plastic limit. What is the value of liquid limit minus plastic? Here plasticity index is how much, sir? 15%. And liquid index is 56%. So minus WP. If we calculate here, plastic limit is nothing but 41%. So let us draw the graph, students. If you draw the graph, without this graph, you cannot solve any problem, students. So please remember this. Here if you talk about the liquid limit, it is how much, sir? Liquid limit is 56. And plastic limit is how much? It is 41. So 41, they are asking at a water content of 45. So here see students, please understand this. Very good, Srujana. Here plastic limit is 41%, liquid limit is 56%. At 45 percentile, what is the state? Here what will be the state? Here the state is plastic state. Are you able to understand, student? Are you able to understand what is this problem? Okay, see, let me explain you in a better way, in the best way. So here they have given you a graph. Okay, see students, here they have given you liquid limit is how much? 56 percentile. And plasticity index is got it as plastic limit. This is liquid limit and this is plastic limit. Plastic limit is 41 percentile. They are asking there is a water content. This is a graph between volume and water content. Now, if you see the water content 45 means it will be somewhere here in between this region. So, what is this region? If you see here it is called solid, here it is semi-solid, and this region is known as plastic state. So, if they ask you at this water content what is the state of the soil, Srujana? The state of the soil at this state will be plastic state. It will be equal to what, sir? Plastic state. Clear, students? Is this clear? Okay. Now see, students. See, this is another beautiful question. They have asked you what is the coefficient of uniformity. Okay. See, students, the question was laboratory sieve analysis was carried out using a complete set of standard sieves. Out of 600 grams of soil, 240 grams was retained on IS 600 micron sieve, okay, and 300 grams was retained on 500 micron sieve, and the remaining was retained on IS 425 micron sieve. What is the coefficient of uniformity of the soil? Clear, student? Is this clear? So they are asking what is the coefficient of uniformity of the soil. So just give a try, student. So here please see, the total weight is given in the problem as 600 grams. Okay. We have sieve sages IS 600 micron sieve and we have IS 500 micron sieve and we also have, my dear students, IS 425 micron sieve. So what is the weight retained on each sieve? So if you talk about what is the weight retained on each sieve, if you talk about how much is the weight retained on each sieve, if you talk about how much is the weight retained on each sieve, here it is 240 grams, okay, here it is 300 grams, and what will be the remaining, sir? Total is 600. Total is 600, out of which 240 was on 600 and 300 on 500. So 240 plus 300 is 540. 600 minus 540 is 600 grams. So the weight 60 grams. So it is 60 grams. So now you are telling about the weight retained. If I talk about the percentage weight retained, how do you calculate percentage weight retained? If I take this as W1, W2 and W3, it is given as W1 by W into 100. That can be written as how much, student? 240 divided by 600 into 100. So you can take this as 40 percentile. How much? It will be equal to 40 percentile. Similarly, if you talk about here 300 by 600 into 100, here it will be equal to 50 percentile. And here it will be 60 by 600 into 100. It will be equal to 10 percentile. Am I clear, sir? So here you have calculated what is the weight retained on each sieve. Now, my dear students, when I talk about the cumulative weight retained, how much is retained on each sieve? If I talk about the cumulative weight retained, this will be equal to how much, sir? It will be equal to 40 percentile upon, next one is 40 plus 50, or you can write here, cumulative means 40 plus 50. This is equal to 90 percentile and the total will be equal to 100 percentile. Here when I talk about percentage finer, or you can write percentage passing, percentage finer or percentage passing, both are same, students. You have to remember that for a given soil, percentage finer and percentage passing is same. So here it is 40 percentile. So 100 minus 40. So 100 minus 40 is how much? It is equal to 60 percentile. Here 100 minus 90. 100 minus 90 is equal to how much, sir? 10%. Here it is equal to 100 minus 100. That is equal to 0%. Here you can write 100 minus 100. So, my dear students, what is coefficient of uniformity, Amma? What do you mean by coefficient of uniformity? Coefficient of uniformity is defined as, it is the ratio of D60 upon D10. So, what does D60 represents? It is the size of the sieve. D60 represents the size of the sieve where 60% is passing. So, here 60% passing means you can directly take it as 600 micron. Are you following, Srujana? Sir, what is D60? It is the size of the sieve where 60% is passing. So, 60% passing is observed in which sieve, sir? IS 600 micron sieve. So, and where do you observe D10? In IS 500 micron sieve, there is a passing of 10%. So, first of all, I told you, my dear students, D60 and D10 are nothing but the sieve sizes. So, here it is 600 micron upon 500 micron. That value is nothing but the 1.2. So, that value is how much? That value is nothing but 1.2. Any doubts in this? Can you look into this problem, Srujana and Abdul? If you have any doubts, you can ask me. Any doubts in this? You can ask me, sir. Is this problem clear? Srujana, can you please respond? Okay, very good, very good. Now, see students, there is another beautiful problem. The following data was obtained in a shrinkage limit test. The initial weight of the saturated soil is 95.6 grams and initial volume of the saturated soil is 68.5 cc. The final dry weight is 43.55, final dry volume is 24. What is the shrinkage limit, specific gravity and initial and final void ratios? So here, my dear students, when I talk about here, when they have given you this problem, first of all, there is a test formula. Shrinkage limit is given by the formula total weight minus dry weight upon dry weight minus of V minus Vd, okay, V minus Vd into gamma Wd into 100. This is the formula for what, students? Shrinkage limit. Now see students, Ws can be written as, what is the total weight of the soil? It was 95.6 grams initially. And they have given you the dry weight. Sir, this formula is useful. Shrinkage limit, this formula is applicable in case of laboratory test. Here the dry weight is how much? 43.5 grams. Divided by, dry weight is 43.5. And now see, minus of, initial volume is how much, sir? Initial volume is 68.55 minus dry volume is 24.1 minus 24.1. 1 second, minus of, I cannot write that. Okay, 68.5 minus how much, sir? 24.1 divided by 24.1. Okay, divided by, what is the value here? What is dry weight? Dry weight is nothing but 43.5. Sir, here gamma W will be taken as how much? Gamma W will be taken as 1, or you can write here gamma W will be taken as 1. Okay. So, what is this value? Can you tell me, Amma? Just multiply with 100 also. 1 second, I will write it here. This minus of V is how much, sir? Total V is 68.5 minus 24.1 into gamma W is 1. Okay, divided by W is 43.5. What is this value? Multiply with 100. Srujana, can you tell me what is this value? You got 90. Sir, very good, very good. What is the value, sir? Shrinkage limit is given as 17.7%. Okay. Clear, sir? Any doubts in this? Very good. Sir, please remember the formula. Here, please, I will write here. In case of laboratory test, shrinkage limit is given by the formula W minus WD upon WD minus of V minus VD into gamma W upon WD into 100. Sir, actually for your information, I will tell you how this formula came also. Sir, what is water content, amma? Water content is nothing but weight of water by weight of solids. So, in case of, if you remove the dry weight, total weight minus dry weight, you will get the weight of water. So, I have done this one only. From here, the volume at shrinkage limit is what, sir? Volume at shrinkage limit. If you talk about the volume at shrinkage limit, the volume at shrinkage limit will be equal to VD. Sir, actually here you have to write weight of water into gamma W. So, whatever the voids are there, they are completely filled with water. Gamma W is gamma W. Weight of water means here, volume of water, sir. Now, weight of water is what, sir? Weight of water can be written as what? I told you already, weight of water can be written as gamma W into VW. So, we have applied that formula and we have got. Clear, Srujana? Is this clear? How this formula was came? Okay. Now, see students, they have asked you the specific gravity of the soil. If they ask you what is the specific gravity of the soil, and they ask you what is specific gravity, you know shrinkage limit is how much, sir? 17.7 percentile. Or you can write shrinkage limit is equal to 1 by Gm minus 1 by G. Okay, shrinkage limit is how much, sir? 0.177 is equal to, what is the mass specific gravity? Sir, you can take either dry weight or shrinkage weight. So, here if I talk about the mass specific gravity in saturated state, it is taken as gamma sat upon gamma W. Okay. You can write this also. Okay. Am I clear, sir? Yes. So, Gm is equal to gamma sat by gamma W. Here, what is the weight of the soil, sir, initially? Saturated weight is 95.6 gram. And the volume is how much, sir? What is the volume? 68.5. So, here gamma sat is equal to weight of saturated by volume upon gamma W can be taken as 1 gram per cc. So, what is weight of saturated? It is how much, sir? Around 93.5, I think. The weight is 95.6 and it is 68.5. 95.6 divided by 68.5. Did I write this only? Okay. When I talk about 95.6 divided by 68.5, what is the value, sir? What is the value of 95.6 divided by? What is the value? 95.6 divided by? The value will be 1.39. So, here it will be equal to 1.39. Okay. Now, see. 0.1779 is equal to 1 divided by 1.39 minus of 1 by G. Can you tell me what is this value? Srujana, very good. What is the value of specific gravity now? What is the value of specific gravity? What is the value of specific gravity? Here you can write, sir. 1 divided by 0.77, right? Minus 0.177. How much value you got, sir? 1 divided by 1.39. 0.719, right? Minus 0.1. 0.177. So, 1 divided by, how much value you got? 0.54, sir. You will get 0.54. 1 divided by 0.54. It will be around 1.85. It will be equal to 1.85. Okay. See, Srujana, we have to do 1 divided by 1.39 is equal to 0.077 is equal to 1 by G. This value will be 0.54. If you 1.139 is divided by how much, sir? Point, how much you got? Please check this value, Amma. Again, I'll check it. Srujna, 1 divided by 1.39, right? So 0.719 minus of 0.177. So 1 divided by that 0.54. You will get a value of 1.85. This is the specific gravity. Okay. Okay. I hope. Now see students, I hope you are clear with the session. Thank you for attending the session, students. Please share this session to all your friends who are very really interested. This is our toppers list. In the GATE 23, we have achieved some results, and these are all the toppers list, sir. And when I talk about the GATE zero fee program, we have 100 plus hours of means the if you visit the imsindia.com, there you can find the zero fee program. It is 100 plus hours of free coaching will be there, and 12 chapter tests, 6 subject tests, and 6 past gate papers. How to register for this is visit imsindia.com, and there you will find a form and fill that GATE zero fee program. Definitely you will get all the things. So what we do at imsindia.com is, IMS India is, suppose see students, we are the pioneers in GATE coaching, and we can say we have done the GATE coach, we are the offering GATE coaching offline at Bangalore and Vijayawada. This is the important point, student. We are the only center who are offering offline coaching at Vijayawada, and we are also providing the offline coaching at Bangalore. At Jayanagar office, you can visit our office and get a demo, free demo classes also. We are providing 800 plus hours of live classes, and what a 130 plus online tests, 20 to 30 theory questions, 1 to 1 12. This is very important, sir. In IMS GATE Academy, from the future, they means from past, they have been following the 1-to-1 mentoring sessions, which is very helpful for the student growth. Suppose they will identify the weakness, they will drive the student that weakness into the strength. And we have doubt solver portal also, and you can see our contact numbers at Vijayawada, Nagpur. We can see the centers. Here, see students, when you talk about the admissions, see here we have the at Vijayawada, my dear students, we are the only center who are offering the offline coaching, and you can visit the bench circle and you can get all the insight. And thank you for attending our session. And remember students, it will be more motivating for the faculty if you can share this session to all your friends. And if the friends who are really great aspirants, just try to understand the foundation course. The agenda of the foundation course is, suppose if you are attending the GATE coaching on geotechnical, after at least after watching these videos, at least you can score how easily you can score. To understand this thing, my dear students, in GATE preparation, my dear students, consistency is very important. Along with the consistency, hard work will definitely matter. But if you are trying to attend the classes regularly on the YouTube, try to follow this channel, for especially for civil engineering and all for the other branches. We have a wonderful team, my dear students. Try to watch the videos. If the videos are really helpful, then please share it. I hope you enjoyed this session. Thank you.